Hello, and welcome to Using Variables in C. My name is Marcus Gardner. Now, if you have looked at my other sequence in Python, you saw how easy it was to use variables in Python. Well, sorry, it's not so easy in C. Okay, but fear not, I'm going to help you show you how to work with it this video and in future videos. Okay. Alright, so let's get started. So we have our code blocks up. First thing we're going to do is hit File, New, and then File, C Source, Next, Next, and then of course C Code, and then we're just going to call it, say, Variables. Okay, save, and finish. Okay, now of course we have our including stdio.h, and then we have int main. Okay, so in Python you can just start using a variable, but in C is a much smaller language. Okay, you have to tell it things. It doesn't know anything. Okay, so for example, if you want an integer, for example I, then you have to tell it it's an integer. So we have int I. So we're telling it it's an integer. And of course we can have a float, let's say temperature. Now remember, when you make a variable, it should be descriptive. So this I, to me, is just like a counting variable, like CT for counter. So many programmers use I for a counting variable. Okay, and then of course you have your character, C. Now of course we have floats, and there's a few other types, but we're not going to get into. Of course we have double. And we have a few other types that we're not going to get into. The most important ones right now are int, float, character, and string. Those are the most important ones for now. Okay? A double is very similar to a float, just more precision. Okay? All right. A string is just a bunch of characters put together. Okay? And the important thing here is that you have to tell it what is the max length. So what this does is it says that the name cannot be longer than 9 characters. The 10th character is what we call a null terminator. It's something that tells the computer, okay, this thing stops here. So, for example, if I did this, what it really has is MARKIS and then null terminator. The null terminator goes right after the S. And then the 8th, 9th, and 10th position is not used at all. Okay? So, we can print out that information. Okay? Now, there is a problem. We haven't said what I was. We haven't said what temp or C is. And if we tried to print those values now, it may work on this compiler, but on another compiler, it may not work. Okay, so let's go ahead and try it. Okay, so printf. Let's see. Let's first print the integer. So let's go ahead and print %d. All right. Let's go and print the letter A, or let's put a dash rather, 2 dashes. And then let's do the float. So %f. Let's put 2 more dashes. And let's put %c, 2 more dashes. %s for our string, and 2 more dashes, and then a \n. Now the \n is a new line. Okay? And let's go ahead and put 2 more dashes. So you can actually see that work. All right? And now, so our %d is our I. Our %f is our temp. Our %c is our C. I don't know what happened here. Changed the line on me. Okay. And our %s is our name. Okay? So what we call these three is uninitialized. We have not initialized them. Now C has a compiler. So it takes this code and turns it into machine code. Okay? That the computer can then read. Actually does a little bit more than that. But for right now, it just takes that information and puts it into a bunch of zeros and ones. And some compiler options will do things. For example, some will initialize the I to 0 and the float to 0.0 and the character, maybe a space, maybe the null character, maybe A. It's just upon the whim of the programmer. Okay, so let's see what happens. Let's see, I got semicolons and everything, so hopefully this will run first time. Yay, now let's run it. All right, so the integer was in fact 0. The float was 0.00000. Character C was space. And then, of course, our name was Marcus. See, even though we told it it's 10 in length, it only printed out the Marcus. Okay? Now, this will not happen all the time. Sometimes you're going to get garbage. Okay? For example, here, let me try another thing here. How about name 2, 10, and we don't initialize it. Okay? So let's put in another %s here and put in name 2. And let's just see what gets printed there. Okay? All right. In an ideal world, it would be the null character. Let's see what happens. And in fact, it was. See, it says nothing was printed. Okay. So, unfortunately, it didn't show you garbage like I was hoping it did. In my test run, it did. What's really happened is that it is allocating some space. But let me show you an example of what happens if, for example, instead of Marcus, I put Marcus at 6, 7, 8, 9, 10. Okay? Now remember, name can only hold 9 because it needs a null terminator. Alright, let's see if anything bad happens, like it did on my test run. Okay, so let's try printing it. And unfortunately, again, it didn't cause any problems. Alright, so this is not working out the way I hoped. Because when you make something too long, is that it will keep printing. If I printed this name under normal circumstances, it would just keep printing a bunch of junk characters until it got to a null terminator. The problem is that this compiler is being very nice. It's that it's terminating everything for us. Okay? So I'm going to try some other things here. Int j equals 2, int k. Let's see here. Let's see if it initializes all of them. Int l. Okay. And then let's do car name 3, 10. And let's just go ahead and start printing all of these. Printf, because I'm really hoping to show you that it doesn't work. %d, that's our j, D, that's our K. Percent D, that's our L. Let's see. No, I've already got that. Okay, so now I've got a percent S. That is name 3. All right, so let's see if I got everything here. So J, of course, that's going to print correctly. K, L, and we already got temp, we got C, we got name and name 2, so let's try name 3. All right. Let's see if all of this worked out okay. Please, no. I forgot my semicolon. All right. All right, so here, finally. Okay, our I this time was 1905600. Okay, that's our I. And then temp was still 0.000. C was still space. Name this time was Marcus1234, comma. Okay. And then name 2 is still null. This time our J still 2, good. Our K still got initialized to 0, but look, L got initialized to 44. And name 3 initialized to nothing. Thank you. You all were beginning to say, Marcus doesn't know what he's talking about. It's always going to be 0. Okay, good. So as you can see, we cannot assume it is going to initialize things. Okay? So if you want things initialized, you have to initialize them yourself. Equals 0. Equals 0. Or whatever value you want to initialize it to. It does not have to be 0. Okay? You can say the initial value of temp is 98.6. Whatever you want. Okay? Character C, A. Alright? And character name 10 equals empty and equals empty. Okay? So, initialize. Do not make assumptions. So as you can see here, it worked the previous run. I was feeling worried, but this time it didn't work. Okay? We don't want I to be 1905600. All right? And we don't want name 10 to be Marcus1234. Okay? That's because we made it too long. The null character is gone. The next character in memory was a comma, and then after that was a null terminator. We got lucky. See? It could have printed 1,000 characters. Okay? All right. So, it is very important that you always initialize things. Okay, good. All right, now we can do math just like we did with the numbers, but now we can do it, with the variables. But, again, make no assumptions. Okay? Let me show you an example here. Let's say int num equals 0. And then num is equal to temp divided by 2. Now, there is a problem here. Temp is a float. 2 is an integer. A float divided by an integer, or an integer divided by a float, or a float divided by float will always give you float. Integer divided by integer will give you integer. So this will give me a float, but I said assign it to num. Okay? All right, so let's see here. Print num. Printf num. All right, now this should give us a problem, but depending on compiler options, it may not. Let's see what we get. first got to close this. And now run it. Okay. So, what did we get? It had an error. Okay. And why is that? Oh, I forgot. Sorry. I forgot. I'm thinking Python here. Okay. So printf %d and then num. All right. There we go. Now let's try it again. Printf double quotes. There we go. No errors now. Okay. So it returned for, let's see here. I don't see where it returned or anything, because this has got 4 values here. That's 4 values. All right. Num. All right, let's put in a \n here. And let's put in a \n, and then let's print 2 more characters. Let's see what I'm missing here. Okay. There we go. The that 4th variable was 49 was what is returned. Now, why did it return 49? Because temp is a float. We're expecting a float. Okay? And we're going to get 49.3, and then it's converting it to an int. So, it did it correctly, but we can't make assumptions. I expected an error. Why? Because this is a float and this is an integer. Okay? We cannot assume it's going to do the correct thing every time. If we want an integer, then we need to cast it to an integer. Then we know it will work on every machine. Okay? Now, maybe this is the way it's supposed to work in all variations of C. But I don't know that. I don't want to spend the time looking in the documentation and see what's going to happen. Okay? I would rather just force the issue and say, okay, I'm going to make you an int, regardless of what's going to happen here. Okay? Even if it's supposed to return an int, it doesn't hurt. Okay? All right, because this is definitely a float. Okay? Now, if in C, when you assign it to an integer, it allows that, then great. I don't know that. Maybe I should know that. Maybe it doesn't work that way. Maybe it's just this compiler. But I don't want to risk it. So, using this int here will force it to an integer. Okay? So, if I want it to be a float, then of course, I need another float. Okay? And then, of course, answer is equal to temp divided by 2. And then let's %f and print the answer. I should have realized that the 49 in the previous line was the answer, but I was expecting an error, so sorry about that. Okay. So, okay, we run it, and let's see. All right. So, we should have gotten 49.3, but we got 49.299. Now, this is one of the things that can happen when you do division, especially divide by 2, okay? And it happens with lots of division. Because, remember, a computer can only work in base 2, which is zeros and ones. Okay? When you divide a number in base 10 by a number like 2 or 3, it doesn't really go well when you translate it into base 2. So sometimes you will have round off error. Okay? So we'll talk about what to do if you need it to be more exact, but much later. Okay? So for right now, realize that this can happen. So one of the things we can do is round it. That's another function of math.h, so we'll worry about that later. Okay? All right, so let me, again, you can use your math.h, include math.h, and then, of course, you can do your exponential, the power, which I showed you before, and the other mathematical operations. All right, so you have enough to do your homework. Now, the other thing about characters, it is not so easy to change characters, strings. Okay, we can do it. We're going to use string.h, which we'll learn later. But for right now, don't worry about changing strings. Okay, you can still print out things using the strings, but don't worry about changing them. Okay, you know, for example, in Python, you can add things to strings, and it'll make a new string. But don't worry about that for right now. Okay. Okay, so we'll talk more about strings in a later video. So for right now, the most important thing is to understand you must initialize, make no assumptions, okay? Know what you're going to get, know what your return values are going to be, force it if you need to. Do not make the assumption the compiler will do it for you. Even if your compiler does, maybe your customers will not. Okay? So you can't make any assumptions. Okay? All right. I do believe that is all the material that you should need for this video. Okay. Thank you very much. Have a nice day. Bye-bye.